Welcome to this explainer. Okay, so let's dive right into the incredibly clever engineering that keeps astronauts breathing on the International Space Station without any grocery runs or open windows. When we look up at the night sky, it's really easy to forget that human beings have been living continuously in the harsh, pitch-black environment of space for over 25 years now. And up there, they obviously don't have the luxury of just stepping outside for a breath of fresh air. Outside the hull of the ISS, there's nothing but an empty, freezing vacuum. So how exactly are they surviving? 400. We're talking 400 kilometers straight up above our heads. At this altitude, in a hard vacuum, there is absolutely zero atmosphere, meaning every single molecule of oxygen that the crew breathes has to be meticulously accounted for. They either have to bring it all the way up from Earth, or they have to figure out a way to manufacture it on board. Which naturally brings us to a massive logistical headache. Where does the air actually come from? Hauling heavy oxygen tanks from Earth all the time is just way too expensive. Rockets aren't cheap, right? Every extra kilogram of weight costs serious money to launch into orbit. So the ISS has to do something far smarter. It literally has to manufacture its own oxygen, continuously, day after day, year after year. Section 1. Splitting water for air. Let's look at the oxygen generation system. So the real secret to getting air in space doesn't involve some massive magical air filter. It actually comes down to ripping water molecules apart, atom by atom. The heart of the whole system relies on a process called electrolysis. Now, as we all know, water is made of 2 hydrogen atoms and 1 oxygen atom, H2O. If you run a strong electric current through water, you can literally tear those atoms apart. The hydrogen collects at one end and the oxygen collects at the other. And where do they get the juice to power this massive reaction? From the station's solar panels, those huge wing-like arrays you always see in photos of the ISS. They generate the raw electricity needed to split the water. Let's walk through the exact steps of how the machine built for this, which is known as the Oxygen Generation System, or OGS, actually works. This cabinet-sized piece of hardware sits right inside the station's US segment. Step 1, it takes in purified water. Step 2, it blasts it with that electric current. And Step 3, it releases that newly freed, totally breathable oxygen straight into the cabin air for the astronauts to inhale. But if you look at that final step, we've got all this leftover hydrogen. Initially, that hydrogen gas was just vented overboard into space, completely useless waste. But as you can imagine, space engineers really don't like waste. Which brings us to part 2, closing the loop and figuring out where that water comes from. So electrolysis requires a massive, steady supply of water. And you obviously can't run a garden hose from Earth to space, so where do they get it? Well, breath, sweat, urine. Yeah, you heard that right. The ISS reclaims almost everything the astronauts expel to fuel those oxygen generators. Every single drop of sweat from their daily workouts, the urine they produce, even the moisture they breathe out into the air gets captured. It all goes straight into a water recovery system where it gets heavily filtered and purified, to the point where it's actually cleaner than most tap water back here on Earth. That reclaimed water then becomes the fuel for making more oxygen. But honestly, it gets even better. Remember that waste hydrogen we talked about a second ago? Engineers got incredibly clever with this. They brought in a device called a Sabatier reactor. This reactor takes that leftover hydrogen and combines it with the carbon dioxide that the crew exhales. And the result of that chemical reaction, well, it produces methane, which gets vented outside, but crucially, it produces more water. And that brand new water goes right back into the system. So the big takeaway here is that this creates a near closed loop. It is just a perfectly engineered cycle. Your breath becomes water through the recovery systems. That water becomes oxygen through electrolysis. And that oxygen is inhaled to become breath again. It's this continuous, beautiful cycle that requires barely any resupply from Earth. Just an incredibly elegant solution to a nearly impossible problem. Moving on to part 3, the backup plans. Let's talk about layers of survival. As brilliant as that closed loop is, you know the golden rule of space engineering, right? Never rely on just a single system when human lives are on the line. When you're 400 kilometers away from the nearest repair shop, you absolutely need backups for your backups. Layer 1 is our primary line of defense, the Oxygen Generation System, or OGS, over in the US segment that we just talked about. Under normal circumstances, this guy handles all the heavy lifting, continuously turning recycled water into the air the crew needs. But hey, things break. If the OGS goes down, whether that's for scheduled maintenance or some sudden malfunction, the astronauts aren't just suddenly left gasping for air. they immediately fall back to layer 2, the electron. This is the Russian segment's own backup electrolysis unit. It does essentially the exact same job as the OGS, stepping in to split water and provide breathable air while the primary system gets fixed. Okay, but what if disaster strikes? Let's say the power goes out entirely, and both electrolysis systems are down at the exact same time. That is when the station relies on a chemical last resort. They keep these solid fuel oxygen canisters on board, which are affectionately nicknamed oxygen candles. When activated, they literally undergo a solid fuel chemical reaction that generates a steady stream of oxygen. It's actually really similar to the emergency backup systems that submarines have used for decades deep underwater. And just in case 3 layers weren't enough, we hit our final redundancy, layer 4. The ISS keeps highly pressurized oxygen tanks right on board, resupplied directly from Earth. The whole thing is built in these overlapping protective layers, specifically engineered so that no single point of failure could ever leave the crew with the absolute most fundamental requirement for human life.
So it kind of makes you wonder, are we taking air for granted? Down here on Earth, we absolutely do. We just inhale and exhale without even a second thought. But when you look up at the night sky and think about those astronauts floating in the pitch-black vacuum of space, remember, they aren't just surviving off a stored tank of air up there. They're breathing a highly complex, meticulously engineered loop that has been running continuously for over 2 decades. Breath into water, water into oxygen, and right back again.
I'm going to leave you with this final thought. Next time you turn on your faucet for a glass of tap water, ask yourself, could you drink your own recycled sweat just to take your next breath? It really puts the absolute genius of space engineering into perspective, doesn't it? If you found this fascinating, stick around. In our next explainer, we're going to dive into exactly how they extract their daily drinking water from this exact same incredible loop.